गुड इवनिंग जेएनवी नगाओ। अपना नाम लिख दिया करो एक बार, ठीक है? स्क्रीन इज विजिबल टू ऑल। ओके, मामोनी देवी, गॉट इट। चलो तो फिर बात करते हैं। सो गुड इवनिंग ऑल। I welcome you all in this session of geometrical optics, and here we will be describing what's the optics is and what's the geometrical input of it. Okay. In this chapter, we have covered about the plane mirrors, deviation of plane mirror. Let me brief you what we have done till now. So basically, we have done with plane mirror. What is a plane mirror is? Apart from that, what is rays, specifically light ray, we have talked about it. Laws of reflection we have covered. Laws of reflection. Okay. And in previous session we have done also the deviation part, deviation of reflected ray from its original path, and velocity of image, velocity of image in different situation, in different situation. So we have described all of this in the previous sessions. If anyone has any kind of doubt in these topics, you can let me know right now. किसी को कोई डाउट है? अच्छा, velocity of image you want. Okay, Sneha. No need to worry. देखो, pay attention. We will done it quickly. Do not worry. Let's say this is the mirror and this is the velocity of mirror. ठीक है? Now this is Vm. So we have two component of it. One in the horizontal direction, one in the perpendicular direction. This component usually we prefer it as V perpendicular, and this component we prefer as V parallel. So this is V perpendicular of mirror velocity, and this is V parallel of mirror velocity. ठीक है? V mirror, and this is the parallel component. Suppose this is the object here we have, it's O. So at equidistance, the image will be formed. If this distance is A, then this image will be formed at A distance on the other side of it. This is image. Let's say the velocity of image is Vi, and this is the two component of velocity of image. Velocity of image perpendicular and velocity of image parallel. देखो, why I am telling it a parallel component, otherwise it, although it's look like a perpendicular component, because this velocities, the velocity of image, velocity of mirror, we measure parallel to the plane with respect reference to the plane of the mirror. ठीक है? So if you will see, the plane of the mirror is in this direction. This is the plane of mirror. So the velocity are parallel to the plane of mirror. That is why this component is termed out as parallel component of mirror velocity, or parallel component of image velocity also. ठीक है. Similarly, we have object here. This is the VO, object velocity. So this component will be VO perpendicular and this component will be VO parallel. अब देखो कॉन्सेप्ट तो यही है, सिंपल सा कॉन्सेप्ट क्या है, वेलोसिटी ऑफ ऑब्जेक्ट with respect to mirror parallel is equals to velocity of image with respect to mirror parallel are same. एक तो ये कॉन्सेप्ट हम यूज करते हैं. ठीक है. कैसे? velocity of mirror refers that it's moving. Yeah, mirror is also moving in this case. So this is a general case I am describing. Suppose this is the mirror. ठीक है, ये मेरे पास मिरर है, ये मेरे पास एक ऑब्जेक्ट है. ठीक है. Let's say my hand is that object. So if I move, the velocity parallel is in this direction. So image की velocity भी इस direction में. So if image is moving with mirror, there is no different in this case. सपोज ये मेरा ऑब्जेक्ट है, इसकी इमेज इस साइड में बनेगी इक्वी डिस्टेंस पे. इफ आई मूव द मिरर पैरेलली, वुड इट बी अफेक्टिंग द पोजीशन ऑफ इमेज? नहीं ना. तो वी कैन से दैट वेलोसिटी ऑफ ऑब्जेक्ट पैरेलल, और सपोज ऑब्जेक्ट ऐसे ऐसे मूव कर रहा है मिरर पैरेलली टू द प्लेन ऑफ मिरर. if object is moving with this speed, so this image will also shift at the same speed. ठीक है. if object is here, image is here. if object is here, image is here. सो सेम टाइम पे ही आपको ऑब्जेक्ट और उसकी इमेज कैप्चर होगी. बट इफ यू आर मूविंग पैरेलल टू द प्लेन ऑफ मिरर, so that is why this concept here is velocity of object with respect to mirror parallel is equals to velocity of image with respect to mirror parallel is equal. Although for absolute velocity you can also write it as velocity of object parallel equals to velocity of image parallel. ठीक है. और ये किसके पैरेलल होंगी? पैरेलल टू द प्लेन ऑफ मिरर. पैरेलल टू द प्लेन ऑफ मिरर. प्लेन ऑफ मिरर, ये मेंशन कर लेना पॉइंट. व्हाट इट नाउ, इफ यू विल सी दैट वेलोसिटी ऑफ इमेज, अब मेरे पास ये अगेन फॉर एग्जांपल ये मेरा मिरर. ठीक है. अगर मेरा ऑब्जेक्ट ऐसे मूव कर रहा है, हाउ टू एक्सप्लेन, या अगर मेरा ऑब्जेक्ट ऐसे मूव कर रहा है विच इज परपेंडिकुलर टू द प्लेन ऑफ मिरर, प्लेन ऑफ मिरर ये, तो ऑब्जेक्ट मेरा ऐसे ऐसे मूव कर रहा है ऐसे, विच इज नथिंग बट द परपेंडिकुलर. ठीक. तो जो इमेज है वो भी तो अपनी पोजीशन शिफ्ट कर रही होगी ना. ठीक है. सपोज यू आर सिटिंग ऑन दिस मिरर, सो यू विल से विद विच स्पीड द ऑब्जेक्ट इज कमिंग, तो इमेज की वेलोसिटी भी सेम होती है बट ऑपोजिट डायरेक्शन. इफ यू कम क्लोजर टू द मिरर, ऐसा थोड़ी होता है कि आप जितना मिरर के पास जा रहे हो उसकी इमेज उतनी दूर बन रही. इमेज आपसे दूर थोड़ी जाती है, पास ही आती है. विच मीन्स ऑब्जेक्ट image is also moving in the direction of image. ठीक है. So for that we can say that velocity of object with respect to mirror perpendicular is equals to velocity of image with respect to mirror perpendicular are same but opposite in direction, and for that I have put minus sign. ठीक है. Now if you open up this expression, finally what you will get, velocity of image, ultimately we are here to find out the velocity of image. So velocity of image perpendicular is nothing but 2 times of velocity of mirror minus velocity of object, absolute velocities. ठीक है. These are the two relation. If you will put here that velocity of mirror is 0, which means mirror is not moving, then velocity of image perpendicular is also equals to negative of velocity of object perpendicular. ठीक है. Clear? Now if I give you a question in this, let's say this mirror is moving with velocity 10 meter per second at an angle of 60 degree. Okay. and this object is also moving. Object velocity is also given to you. Object velocity is 5 meter per second, and the angle is from the horizontal. The object is moving with 30 degree Celsius. Okay, at a 30-degree Celsius angle, sorry, 30-degree angle, velocity of object is given 5 meter per second. Now, how to calculate एब्सोल्यूट वेलोसिटी रेफर्स टू, अब ये भी बहुत इंपॉर्टेंट पॉइंट है, और ये किसने उठाया भाई? वेरी गुड, जेनवी नगाओ। जेनवी नगाओ ने अभी अपना नाम भी बताया था ना, या मामोनी देवी, वेरी गुड मामोनी। देखो, एब्सोल्यूट वेलोसिटी का मतलब होता है, एब्सोल्यूट, एक्चुअल में तो कुछ भी एब्सोल्यूट नहीं है, लेकिन एब्सोल्यूट वेलोसिटी विल रेफर्स द वेलोसिटी विद रेस्पेक्ट टू ग्राउंड, विद रेस्पेक्ट टू ग्राउंड, ठीक है, और स्पेसिफिकली इनर्शियल फ्रेम। तो जिस इनर्शियल फ्रेम में जब हम वेलोसिटी को मेजर करते हैं, दैट वेलोसिटी इज एब्सोल्यूट वेलोसिटी, एंड दैट इज विद रेस्पेक्ट टू ग्राउंड। सो ग्राउंड की यहाँ पे मतलब बिल्कुल जीरो से, जहाँ पे फ्रेम की वेलोसिटी कितनी है, जीरो, बिकॉज ग्राउंड तो कहीं भी मूव नहीं कर रही है ना। इफ वी आर सिटिंग हियर, देन वी आर मेकिंग सम दिस ऑब्जर्वेशन, although ground is also moving with respect to sun, with respect to its own axis, but do not consider that things, ठीक है? Try to solve this. Find the object image velocity perpendicular and velocity of image parallel. सोल्व करो, 1 मिनट है आपके पास. In 1 minute, try to solve this question. And everyone has to respond. There are 29 students here. तो जो समझता है कि हाँ, I have to make some point here, try to solve this question. At least फिर आप 60% स्टूडेंट को तो ये सोल्व करना ही चाहिए, ठीक है? दोनों फॉर्मूला आपके सामने है, वेलोसिटी ऑफ ऑब्जेक्ट एंड वेलोसिटी ऑफ इमेज पैरेलल और वेलोसिटी ऑफ इमेज परपेंडिकुलर, बोथ इज इन फ्रंट ऑफ यू, ठीक है? चलो, मैं भी सोल्व करता हूँ साथ में, यू कैन मैच योर आंसर. फर्स्ट ऑफ ऑल, आई हैव टू कैलकुलेट व्हाट इज द एब्सोल्यूट वेलोसिटी कंपोनेंट. सो वेलोसिटी ऑफ ऑब्जेक्ट इज गिवन, वेलोसिटी ऑफ ऑब्जेक्ट का पैरेलल कंपोनेंट, व्हिच मींस दिस वाला, ये कंपोनेंट कितना है? इट विल बी 5 sin 30. It could be 5 sin 30. Resolve कर लो velocity, and it is coming out as 5 sin 30 means 1 by 2, which is 5 by 2 meter per second. This is velocity of object parallel. Velocity of object perpendicular कितना होगा? 5 cos 30, which is 5 root 3 by 2 meter per second. Similarly, velocity of mirror को भी resolve करो. Velocity of mirror parallel is equals to 10 cos 60, sorry, 10 sin 60, this one. Velocity of mirror parallel, 10 cos 10 sin 60 will become 10 root 3 by 2 meter per second. Okay, let me change the color here. And velocity of mirror perpendicular is coming out as this component, this one. It is 10 cos 60, which is 5 meter per second. Cos 60 is 1 by 2. अब देखो आपके पास चारों वैल्यू, velocity of mirror parallel, velocity of mirror perpendicular, object perpendicular and object parallel. Velocity of object parallel is independent of mirror velocity. यहाँ से देखा. So velocity of object parallel is equals to object parallel is कितना है? 5 parallel is 5 by 2 meter per second. Okay. Now what is velocity of image perpendicular? इसके लिए 2 times of velocity of mirror perpendicular minus velocity of object perpendicular. Now here you have to pay attention that you need to put the symbol with sign. So I have considered this direction to be positive and opposite of it will be negative. Okay. So ये positive हुआ, which means all the velocities that I measure in this direction, left to right, will be positive, and all the velocities from right to left will be negative. So if you will see the mirror velocity perpendicular is left to right, which is we can consider positive. So 2 times 5 minus velocity of object perpendicular is upward. Upward we can consider positive, downward we will consider negative. ठीक है. So velocity of object perpendicular is 5 root 3 by 2. 5 root 3 by 2. ठीक है. Which is nothing but n minus 5 root 3 by 2 meter per second. So we have find it out what is the velocity of image perpendicular and what is the velocity of image parallel. दोनों velocities आपके पास है. आई कैप और जे कैप के साथ प्रॉपर फॉर्म में भी लिख सकते हो. बट यू नीड टू रिमेंबर फॉर द पैरेलल कंपोनेंट दिस इज वीओ पैरेलल के साथ जे कैप आएगा because it's a unit vector in the perpendicular direction, and for perpendicular component of velocity you put on I cap. Okay, this thing you need to remember. I hope those are having doubt in this got cleared. So Sneha, is this clear to you? JNV Nagao मतलब मानो. वेरी गुड. अभी कोई क्वेश्चन आएगा तो सोल्व कर लोगे ना, मामोनी देवी एंड ऑल. ठीक है. लेट्स जस्ट मूव विद द नेक्स्ट टॉपिक which is the number of image formed by two inclined mirror. ठीक है. अब ये मेरे पास दो inclined plane mirror है. कौन से मिरर है? प्लेन मिरर. तो प्लेन मिरर है तो नंबर ऑफ इमेज अगर मैं ऑब्जेक्ट यहाँ पे कहीं भी प्लेस कर देता हूँ, दिस इज द पोजीशन ऑफ ऑब्जेक्ट. ठीक है. then how many images due to these combination of the mirror will form? So it will depends on the angle theta and the position of this object. ठीक है. if the object if the object is placed at the perpendicular bisector of the angle at angular bisector at angular bisector, then number of images, देखो ये जनरल फॉर्मूला है, number of images is equals to 360 अपॉन थीटा माइनस 1. ठीक है. कितनी इमेज बनेगी? 360 अपॉन थीटा माइनस 1, और थीटा ऑलवेज बी इन डिग्री. सो फॉर एग्जांपल लेट्स से थीटा बिटवीन दीज टू एंगल इज गिवन एज 90 डिग्री. ठीक है. सॉरी, इसके लिए आपको क्या करना पड़ेगा? पहले इससे भी पहले जस्ट फॉर अ मोमेंट, ये बाद में आने वाली लाइन थी, पहले बता दी मैंने आपको. गिव मी अ सेकंड. So the formula of number of images is this. Firstly, you need to consider that n is equals to 360 upon theta. N is the number of images. If the first case is if n is equals to even number, which means number of images are coming out as even, then number of image is equals to n minus 1 wherever the position of particle, it is independent of position of particle of position of particle, which means मेरा particle या object ऑब्जेक्ट मेरा कहीं भी हो, wherever we put the object, the number of images is coming out as n minus. For example, for example, let's say theta is given as 90 degree. So n is coming out here is 360 upon 90, which is 4. So this is even. This is an even number. So number of images, let's say I is nothing but 4 minus 1, which is 3. So कितनी images बनेंगी इस object की? 3 images will be formed. Got it? Clear है? अब देखो. Now, if second case is that n is equals to odd number, if n is equals to odd number, then there are two conditions. There are two conditions. If particle is present, particle is present at एंगुलर बाइसेक्टर. तो अगर पार्टिकल एंगुलर बाइसेक्टर पे है, तब जो नंबर ऑफ इमेजेस बनेंगी, नंबर ऑफ इमेजेस n माइनस यार. So if the particle is not present at angular bisector, then the number of images will be number of images is equals to n on a. ठीक है, क्लियर हुआ? So this is the formula we have 360 upon theta. Firstly, you need to calculate. The question will provide you the value of theta. Then you need to divide 360 with the provided value of theta. You will get a value of n. Then you have to look at the position of the object. Firstly, you need to check whether n is even or odd. If n is even, then you do not need to check whether the position of the object is, where the object is. Simply the number of images will be n minus 1. Okay? But if n is coming out to be as odd number, then if the particle is present at the angular bisector, and what does it mean? Particle is present at this line, which is a line of theta by 2. This angle is also theta by 2. This angle is also theta by 2. Okay? So this kind of position is the angular bisector position. Okay? Then the number of images will be n minus 1. Or agar particle is present not on the angular bisector and the number n is coming out as odd, so number of images will be equal to the odd number only. Okay? That number. For example, try to solve this question. Calculate the number of images formed by two plane mirror kept an angle of 30 degree, 72 degree, and 90 degree respectively. Assume the object is placed symmetrically with respect to both the mirror in all the three cases, which means that the object is already placed at the angular bisector. Now you just have to check what is the value of n. Okay? If it is even and odd, then calculate the answer. I am doing the first one for you. So theta for the first one is 30 degree. So n will become 360 upon theta, 360 upon 30, which is nothing but 12. Okay, 12 is nothing but a even number. So what I have told you, for even number, the number of images will be n minus 1. Wherever the particle is, पार्टिकल के जो इमेजेस बनेंगे कितने बनेंगे? 11 बनेंगे. Very good, Rukmani. Rukmani has solved it for all the three cases. Absolutely correct. Very good, Aishwarya. Janvi Kokraj are also. Absolutely good, yaar. Very good. Getting the concept is a very good thing to know. So here for 72 degree, you need to again divide n, which is 360 upon 72. अब देखो ये 12 बारह दिया, 12 चुक 12 थ्री जा 36, 36 का 2 टाइम्स 12 4 जा, है ना? 72 and 12 3. This is coming out as 30. Then 2 and 15. So here the n is coming out as 7.5. ठीक है, तो 7.5 के केसेस में अब देखो ये तो एक इंटीग्रल वैल्यू नहीं है. ठीक है, वेरी गुड. और ये ऐसी क्लास में अच्छा लगता है जब स्टूडेंट रेस्पॉन्स करते हैं ना. वेरी गुड. अच्छा 6 टाइम होता है. आई एम रियली सॉरी. ये 6 टाइम होता है यार. 6 टाइम होता है. सॉरी सॉरी सॉरी. 12 6 या 72. 6 एंड ये आ जाएगा 30. देन एन इज कमिंग आउट एज 5. और 5 क्या है? मेरा ओड नंबर है. ठीक है, बट द ऑब्जेक्ट इज प्लेस सिमेट्रिकली. तो अब अगर ऑब्जेक्ट सिमेट्रिकली है, विच मीन्स एंगुलर बाइसेक्टर पे है. एंगुलर बाइसेक्टर इज ऑल्सो सिमेट्रिक, सिमेट्रिकली. ठीक है, देन द नंबर ऑफ इमेज इज n minus 1, which means 4. So here the number of images coming out as 4. तो देखो दो ऑप्शन तो मैच हो ही गई, 11 और 4. अब यहाँ पे भी देखो कंफ्यूजन, इन दोनों में से कौन सा सही है. तो 90 के लिए सीधा डिवाइड कर दो. देन n विल बी कमिंग आउट एज 4. 4 is even, so this will be n minus 1, which is 4 is minus 1 equals to 3. The number of image will be 3. So 11, 4 and 3 is the right answer. Those who have participated in this, very good. Very good, Madhukar. Absolutely correct, everyone. Those who have responded. Now let's just talk about some concept of spherical mirror. Okay. अब देखो spherical mirror क्या होता है. We have a sphere first of all. Firstly, let's just understand that how these mirrors, spherical mirrors are formed. ठीक है. Suppose we have a sphere. This is the sphere. It's the 3D object. ठीक है. Now you have a plane like this, and this plane is very sharp at the ends. You place that plane perpendicular to this above, perpendicularly above this sphere, and cut down the sphere. So when you cut it down from this section, you will be having a section like this, exactly at half. ठीक है. So this curved part of the this curved part is nothing but spherical mirror. ठीक है, अभी समझ में आया क्या क्या? मेरे पास एक स्फेयर है, उस स्फेयर को मैंने बीच से काट दिया. आई हैव पुट अ प्लेन ऑन द राइट एट द मिड ऑफ दैट. देन आई गॉट टू हेमीस्फेयर. ठीक है, so that curved part of that hemisphere is forming a spherical mirror. Got it? Now, अब यहाँ पे दो रेडियस इन्वॉल्व हैं. Try to understand it. One of the radius of the sphere, this is the radius of sphere. But when we cut it down into a part of hemisphere, or not. Let's say the part is, we have cut it down here, although it's a part of the spherical, this is also a part of sphere, this portion is also the part of sphere. Got it? क्लियर? तो अगर इस, ये इस तरह का ऑब्जेक्ट है, ऐसा कर्ड है, इसे अगर सामने से देखोगे आप, इफ यू जस्ट टर्न इट एंड व्यू इट फ्रॉम द टॉप, इट विल लुक लाइक दिस ओनली. ठीक है, इट विल लुक लाइक दिस ओनली. सो देर आर टू रेडियस, एक तो इस पार्ट की रेडियस और एक स्फेयर की रेडियस है. ये जिस स्फेयर का पार्ट है, ये जिस स्फेयर का पार्ट है, एक तो ये रेडियस है, और इस, ये जो सर्कुलर पोर्शन आया जो मेरे सामने, ये भी तो एक रेडियस होगी ना, यहाँ से यहाँ तक, ये भी एक आर डैश है. तो यहाँ पे दो रेडियस इन्वॉल्व है, यू हैव टू थिंक अबाउट इट. ठीक है, एक तो कर्ड पार्ट की, जिसको परफेक्ट स्फेयर का जो भी पार्ट है उसकी रेडियस, जिसे रेडियस ऑफ कर्वेचर बोलते हैं. एंड द सेकेंड पार्ट इज ये जो आपको सामने दिख रहा है फेस, जिसमें हम अपना फेस दिखता है. ठीक है, नॉट टॉकिंग अबाउट प्लेन मिरर, स्पेरिकल मिरर जब भी किसी ने अगर देखा हो, वो जो जिसमें दिख रहा है ना, वो वाले पार्ट की जो रेडियस है सामने से, दैट इज डिफरेंट देन द रेडियस ऑफ स्फेयर. And I hope that you got this concept. Now, again move back to this topic. In this topic, if you will see, spherical mirror are defined as the curved mirror, and that is nothing but a part of a hollow sphere. So, based on the reflection, which part is reflecting the light, we describe the hollow mirror or the spherical mirror into two parts. First is concave, second is convex. What is concave? What is convex? So, if this, let's say this, मैं हाथ से बना नहीं सकता. If you can imagine this, this is the curved part from inside, and this is the curved part from outside. So if this surface is reflecting the light, the surface which is bulging out, okay, if this part is reflecting the light, then that mirror is convex mirror. And if the inner part of the surface, inner part of that spherical mirror is reflecting the light, then that mirror is concave mirror. I hope that you got it. ठीक है. So curved mirror is that part of a hollow sphere which is a part of hollow sphere only. And if the reflection is taking place from inner surface, let me change the color here. If the reflection is taking place from the inner surface, then the mirror is called concave mirror. And if its outer surface acts as a reflector, then that part is a convex. तो उस मिरर को हम क्या बोलेंगे? कन्वेक्स मिरर बोलेंगे. ठीक है. Am I audible to everyone? Screen is visible to everyone? Let me know. So there are two types of spherical mirror, convex and concave. We have already discussed what part is convex and what part is concave. ठीक है. Thank you मधुकर for the confirmation. देखो, ये भी एक स्फेयर है ना, ये होलो स्फेयर है. ये मेरा जो पार्ट लिया, देखो यहाँ पे आपको क्लियरली विजिबल होगा अबाउट विच रेडियस आई एम टॉकिंग अबाउट. देखो, this is the radius of this sphere only, capital R. But if you cut that mirror, you will finding out a space inside it. ये ये भी तो एक सर्कल ही है ना. This portion is also a circle. इसकी जो रेडियस होगी, that is a different thing from here to here. ये भी तो एक रेडियस होगी. This is R dash. ये अलग रेडियस है. देखो, when ये जो इस तरह से हम ड्रॉ करते हैं ना, लाइन लाइन लाइन, इसका मतलब होता है कि दिस पार्ट ऑफ द सरफेस इज रफ. दिस इज रफ इन दिस टाइप, which means reflection cannot take place from this side. And in this mirror, the reflection will be taking part from the outer side. So this part is rough, inner part is rough. Got it? So if you will see, the light is coming and after reflecting, it is moving back. In this also, Light is coming and moving back. Clear? Now, there are some terminology related to mirrors that you need to understand. The first is paraxial ray. Paraxial rays are those rays which are parallel to the principal axis. Okay. Now, what is principal axis? Let me brief you here. Suppose this is a part of a sphere, hollow sphere, and this portion, this is a concave mirror. This is a concave mirror. मैं यहीं पे ही आपको सारी चीजें एक्सप्लेन कर दूं. द मिड पार्ट ऑफ दिस, ये जो पार्ट है ना, ये कर्ड पार्ट जो है, इस कर्ड पार्ट का जो मिड पॉइंट है, यानी कि ये पॉइंट, this point is termed as pole of the mirror. The midpoint of the portion that we have cut, or midpoint of the reflecting surface. Midpoint of the reflecting surface is termed as pole. ठीक है. अब ये जिस स्फेयर का पार्ट है, जिस स्फेयर का ये पार्ट है, उसकी अपनी एक रेडियस होगी, उसका अपना एक सेंटर होगा. This point is C, and if you connect it, this is the radius of curvature. ये क्या बोलते हैं? सेंटर ऑफ कर्वेचर. इस सी को हम क्या बोलते हैं? सेंटर ऑफ कर्वेचर. Got it? Pole is the midpoint of the reflecting part. Okay. Then here will be a new term which is focus. After reflection, the paraxial ray cut this axis. Or first of all, understand what this axis is. This axis is principal axis. Principal axis. Now, why it is principal axis? Because it is crossing the center of curvature, focus, and pole. So, a axis which passes through the center of curvature, focus, and pole of the mirror, that axis would be termed as principal axis. Okay. Now, if a ray coming to this, if a ray come to any part parallel to the principal axis, if the ray is coming parallel to the principal axis, it will always reflect back and cut through the pole. वो जहां जिस पॉइंट पे कट करेगी उसे हम क्या बोलते हैं? फोकस बोलते हैं. This F here is nothing but the focus of the mirror. कि रिफ्लेक्शन के बाद मिरर कहाँ पे रेज को फोकस कर रहा है, कहाँ पे आपको ब्राइटर स्पॉट, कहाँ पे आपको इमेज मिलेगा. ठीक है. नाउ हियर paraxial rays. These rays, the rays which have very small angle of incidence, are known as paraxial. Paraxial देखो, पैरा प्लस एक्सियल, जो एक्सिस के साथ पैरेलल हो, these rays are called what? Paraxial rays. इनका जो एंगल ऑफ इंसिडेंस होता है वो क्या होता है? बहुत कम होता है. विच मीन्स अगर मेरे पास कोई पैराएक्सियल रे है, दिस इज द प्रिंसिपल एक्सिस, इफ देर इज अ पैराएक्सियल रे और ये रिफ्लेक्ट बैक करेगी, तो यहां से रिफ्लेक्शन हुआ फ्रॉम दिस सरफेस, ये जो एंगल होगा इंसिडेंस, दिस इज द एंगल ऑफ इंसिडेंस टू द नॉर्मल. ये नॉर्मल लाइन, लाइन ऑफ नॉर्मल. ये जो थीटा होगा, थीटा वुड बी वेरी स्मॉल, बहुत बहुत छोटा, very small. Okay. And in this entire chapter we will be considering all the rays which is reflecting, or wherever the reflection or refraction will take place, we consider those rays to be paraxial rays. Okay. Now pole or vertex किसे बोलते हैं? I have told you, it is a point on the mirror from where it is easy to measure the object or image distance. ये भी एक reference point आप कह सकते हो. Second thing is, it is the mid portion of the reflecting surface, exactly at the midpoint. Clear? Center of curvature are those. This mirror is a part of sphere. So the radius of that sphere, the center of that sphere is termed as center of curvature. Okay. The center C of the sphere, which is spherical mirror is a part, is termed as center of curvature. Similarly, for radius of curvature also, स्फेयर का पार्ट है, उस स्फेयर की जो रेडियस है, दैट इज द रेडियस ऑफ कर्वेचर। ठीक है। नाउ दिस इज प्रिंसिपल एक्सिस, इफ यू विल सी हियर, the line joining pole center of curvature of the mirror is known as principal axis or optical axis। ठीक है। सो इन बोथ द मिरर इफ यू विल सी, अब देखो इस पोर्शन के लिए सेंटर ऑफ कर्वेचर आउटसाइड में बना है, यहाँ पे बना है सेंटर ऑफ कर्वेचर, और पोल यहाँ पे है। ठीक है। इसके लिए मैं आपको बताऊंगा व्हाई इट इज हैपनिंग सो। और इस वाले मिरर के लिए विच इज नथिंग बट द कनकेव मिरर, ये क्या है, कनकेव मिरर, इसके लिए सेंटर ऑफ कर्वेचर है। This line or this axis is passing through pole and center of curvature is termed as principal axis। Got it? अब देखो, चलो, what is focus then? Focus is nothing but the, if the rays are parallel to principal axis and paraxial, then the point of which they appear to converge is known as focus। अब इसे समझने के बहुत सारे तरीके हैं। ठीक है। In which one of the most famous method I am telling you, focus is that point on which, after reflection of the paraxial rays means the rays which are parallel to the principal axis, ठीक है, after reflection of these rays, wherever they cut the principal axis, that point is the focus of that mirror. The mirror is trying to focus those rays. So that point is nothing but the focus. Okay. Although you can remember this definition also, it's also good to remember. If rays are parallel and paraxial, then the point on which they appear to converge, देखो यहाँ पे converge होती हुई appear हो रही, it is converging। converging का मैंने क्या बताया था? If you will see between these two planes, the distance between the rays is decreasing, so these rays are nothing but converging in nature। ठीक है, which are moving towards a point। These rays are converging, and when the rays move away from the point, they appear to be diverge. They said to be diverge. Now, why it is has used appear term here? Because in this example, if you will say the rays coming, it reflect back, which means it never going to be meet at focus. So that is why we can assume that these rays are coming from this point, this focal point। So इसलिए हम appear term use कर रहे हैं। It is not definite कि these ray would meet at the focal point। It can be in the second situation, they will appear to meet at that point। ठीक है। So for concave mirror, the focus in the real side, this side is real side, and this side of the mirror is virtual side, which does not exist। So for the case of this, if you will see, for concave mirror, focus is appearing on the virtual side, virtual side। Clear है? length of the length of the pole length from the pole to the focus is termed as focal length। So focal length, यहाँ पे बहुत इंपॉर्टेंट पॉइंट है, focal length is nothing but the distance between pole and focus of the mirror। Okay, that is termed as focal length। Yeah. So focal length is the distance PF in the previous case between pole P and focus length L on the principal axis। Now वो जो radius के बारे में मैं बात कर रहा था कि that radius would be different, here is that part। So the line joining the end point of the spherical mirror, देखो यहाँ से शुरू हुआ spherical mirror starting from M ending at M dash। So the line joining this M and M dash इज टर्म्ड एज अपर्चर। ठीक है, तो किसी भी लेंस को भी देखोगे ना आप, तो वो लेंस का जो ये सर्कल होता है, ये वाला पार्ट होता है, वो जो गोलाई होती है, उसे अपर्चर बोलते हैं। तो जितना बड़ा अपर्चर होगा लेंस भी उतना ही बड़ा होगा। ठीक है, सिमिलरली जितना बड़ा अपर्चर होगा यहाँ पे मिरर में, उस केस में मिरर भी उतना ही बड़ा होगा। ठीक है, so the line joining the end points of spherical mirror is called the aperture or linear aperture। ठीक है, और ये अपर्चर लाइन क्या है, ये लाइन क्या है, इसे सामने से देखोगे तो इट इज अपियरिंग एज द डायमीटर ऑफ दिस पोर्शन, और इसे ही हम क्या बोलते हैं, अपर्चर बोलते हैं। तो ये इसे डायमीटर की तरह भी कंसिडर कर सकते हो। ठीक है, दैट इज टर्म्ड एज अपर्चर। फोकल प्लेन क्या होता है, द प्लेन पासिंग थ्रू फोकस एंड परपेंडिकुलर टू द ऑप्टिकल एक्सिस कॉल्ड फोकल प्लेन। ठीक है, नाउ दिस इज वेरी इंपॉर्टेंट हियर, relation between focal length and radius of curvature। focal length and radius of curvature, देखो, we have taken the example of concave mirror here। okay, अब देखो इस concave mirror में if you will see, just a second, here for example, this ray is paraxial ray. First of all, it is satisfying the condition, this ray is paraxial ray which is after reflection cutting down this part। अभी तक हमने ये डिसाइड नहीं किया कि ये पार्ट जो है वो फोकस ही होगा। फोकस वो कब होगा, जब दिस रे विल बी अपियरिंग एज अ पैराक्सियल, व्हिच मींस एंगल ऑफ इंसिडेंस इज वेरी वेरी लेस। ठीक है, फॉर नाउ वी विल बी कंसीडरिंग दैट आफ्टर रिफ्लेक्शन दिस रे कट एट दिस पॉइंट व्हिच इज बी। क्लियर, नाउ हियर वी हैव अ ट्रायंगल, इन triangle, so condition here is that if incident ray is paraxial, then in triangle ABC, sorry, in triangle ABC, you will see in this triangle ABC, in triangle ABC, AB would be equals to BC or CB। This is the condition, AB और BC क्या होंगे, सेम होंगे। ठीक है, अब देखो, एक तो ये कंडीशन होगी हमारे पास, दूसरी कंडीशन क्या लगा सकते हैं, देखो यहाँ पे दो ट्राइंगल और है, एक तो दिस वन, एक दिस वन। ठीक है, now what we can say here, AC is nothing but रेडियस ऑफ कर्वेचर। देखो सेंटर से पॉइंट को ज्वाइन कर रही है टू दिस पार्ट, सो दिस AC इज नथिंग बट रेडियस ऑफ कर्वेचर। क्या मैं AC को लिख सकता हूँ, AC इज इक्वल्स टू AD प्लस CD? इसमें कोई किसी को कोई प्रॉब्लम है, कोई प्रॉब्लम नहीं होनी चाहिए। अल्टीमेटली आई हैव टू रिलेट दिस BP विद CP। ठीक है, एंड दिस CP इज ऑल्सो व्हाट, CP is also what R, which can also be written as CB plus BP, CB plus BP। In this also you don't have any problem। Clear, clear है सभी को। अब देखो this CD, if you focus on the CD, CD is nothing but the component of this CB in this direction, horizontal component ये वाला। तो we can write CD is equals to BC cos theta, or what you can do, if somebody is having problem in that. Let's just consider triangle CDB and apply cos theta in this. So in triangle CDB में अगर आप cos theta लगाओगे, so उसके लिए CD will become base and BC will become hypotenuse. So CD upon BC, which is base upon hypotenuse. So CD is coming out as BC cos theta. ठीक है, CD is coming out as BC cos of theta. And similarly, this distance BD is also you can write BC cos of theta, but BD की हमें अभी रिक्वायरमेंट नहीं है, तो इसके लिए we do not know anything. ठीक है, we don't want anything to be here. Clear? अब देखो, can we put this value of CD in this equation number 2? Then AC will become AD plus BC cos of theta. AD plus BC cos of theta. देखो, somehow we have to relate this AD also. Got it? Try to note up to this point, then we will be discussing the next point of this derivation. अभी इतना नोट करो आप. Whenever you get to note it, just let me know in the chat box. Okay. Clear? Now, in the triangle, if you will see, in this triangle, BDA and triangle CDB, ठीक है, इन दोनों ट्राइंगल की वजह से we can also say that CD here is also equals to AD. So CD is also equals to AD. ठीक है, अब देखो CD की वैल्यू हमारे पास पहले ही है B cos theta. Put it here in this equation. What it will become? So AC would become as AD is nothing but CD and CD is nothing but BC cos theta. So it will become 2BC cos of theta. Now from this equation, BC is coming out as AC, which is nothing but radius of curvature upon 2 cos of theta. ठीक है, now we have this equation 1, equation 3 to calculate BP. Actually we want to calculate BP, and this equation is R is equals to BC plus BP. तो BP कितना होगा? BC R minus BC. R minus, what is the value of BC? It is R upon 2 cos of theta. This is the formula, and this BP is nothing but the focal length. So focal length is equals to R minus R by 2 cos theta. ठीक है, if theta is very very small, ठीक है, और these rays are paraxial rays, तो उसके लिए थीटा को मैं क्या कंसिडर करूंगा? थीटा इज वेरी वेरी स्मॉल. theta is very, very small. So for that, cos theta is approximately considered as 1. ठीक है? So focus will become r minus r by 2, which is r by 2. But this is very, very important relation, that focus of a mirror, of any spherical mirror, the focal length of any spherical mirror is half of the radius of curvature. Clear? Now, this is very important about sign convention here. साइन कन्वेंशन को याद रखना है, क्योंकि साइन कन्वेंशन इज प्ले अ वेरी क्रूशियल रोल बाय सॉल्विंग व्हेन वी सॉल्विंग न्यूमेरिकल्स based on optics. So always remember the upside when we measure the distance in upper side is considered to be positive, and whenever we measure the distance in downside it is considered as negative. Now for left and right, each and everyone has its own assumption, but the simplest way to remember it, if you measure any distance from left to right, which means in the direction of incident ray, this is the incident ray, this is the incident ray, this is incident ray. So if you measure any distance in the direction of incident ray, it is considered positive. और रिफ्लेक्टेड रे कैसी होगी? इस तरफ होगी, ठीक है? रिफ्लेक्टेड रे इज ऑपोजिट वे, दिस इज रिफ्लेक्टेड रे. So always measure the distance. If you measure the distance in the direction of reflected ray, is considered as negative. ठीक है? क्लियर है? अब देखो, ये मान लिया मिरर का पोल है, ये कोई भी मिरर है मेरे पास ऐसा, ये मिरर का पोल है. इफ यू कमिंग at this side, ultimately you are moving in the reflected side. Ray is getting reflected and you are moving here. So if you measure the distance in the reflected ray direction, then it will be considered as negative. If you measure the direction in the incident ray direction, it will be considered positive. Upside, if you are measuring, it will be positive. Downside will be negative. Very clear. Now, what is mirror formula? There is no need to be derive it. Only remember the formula. Suppose there is a spherical mirror, which is nothing but the concave mirror we have considered. This is the principal axis. Okay. Now, suppose we have placed the object here. This is the object. What it is? It is object. और इसकी इमेज कहीं यहीं पे ही बनेगी. फॉर एग्जाम्पल अभी आप समझ लो कि इमेज इज फॉर्म्ड. दिस इज द इमेज. सो the distance of image from the pole, this is point P, pole, and this is, let's say, I. This point is I and this point is O. So PI is equals to consider as V, which is the distance of image from the pole. Distance of image from the distance of object from the pole is PO or OP. OP is considered as U, and let's say this point is focus. Here is the F, which is the focus of the mirror. Then this distance, which is PF, is equals to the focal length of the mirror. So according to mirror formula, 1 upon F is equals to 1 upon E plus 1 upon. Clear? Where U, V and F need to be put according to sign. So to note it here, for concave mirror, F is considered to be negative, focus is negative. For convex mirror, focus is considered to be पॉजिटिव. देखो, कनकेव मिरर रिफ्लेक्शन के बाद इसी डायरेक्शन में तो फोकस करेगा ना, ऑन द रियल पार्ट. और उसे मेजर करने के लिए आप मूव किस डायरेक्शन में कर रहे हो? रिफ्लेक्टेड रे की डायरेक्शन में मूव कर रहे हो. इसलिए द डिस्टेंस वी मेजर्ड इन द रिफ्लेक्टेड रे डायरेक्शन इज कंसिडर्ड नेगेटिव, ठीक है। बट अगर आप कनकेव कॉन्वेक्स मिरर का केस देखें, तो ये रे आई रिफ्लेक्ट होके यहाँ से चली जाएगी, तो इट विल अपीयर कि ये यहाँ से आ रही है। एंड इफ द रे इज अपीयरिंग फ्रॉम हियर, व्हिच मींस दिस इज द पॉइंट ऑफ फोकस, ठीक है। So this focus is measured in the direction of incident ray. That is why focus of convex mirror is positive. Clear? Sure. Now in the next lecture, we will be talking about, I have launching a poll. We will be talked about magnification of the mirror in the next case, and laws of refraction. And most probably कल तक mirror को at least खत्म कर देंगे, ठीक है। So I'm launching a poll. Please do participate in this poll for marking your attendance. Meanwhile, we are solving this question also. So JEE 2024 क्वेश्चन, अच्छा इसमें मैग्निफाइड वर्चुअल इमेज बाई प्रोड्यूस्ड है, ठीक है। इफ द डिस्टेंस बिटवीन द ऑब्जेक्ट एंड इट्स टू टाइम्स मैग्निफाइड वर्चुअल इमेज produced by a curved mirror is 15 centimeter, the focal length of the mirror must be what? F is question mark here. What is given? It is given the distance between object and its two times magnified virtual image produced by the curved mirror is 15 centimeter. So ये जो आपको given है ना, ये u minus v given है, which is 15 centimeter, ठीक है। So grab this question for your next session. Next session में magnification discuss करेंगे, उसके बाद this question will be discussed, ठीक है। Clear है? Till then, if you have any kind of doubt, you can ask right now. Otherwise, the lecture is being over. Thank you so much for being attentive and being responsive. Bye bye. Take care.